10 insane differences about James Webb and Hubble NASA wouldn't tell you. The James Webb Space Telescope, or JWST, is NASA's most lavish and ambitious space endeavor ever done in quite some time. The telescope's launch gathered all the headlines when it was launched off into space. Alongside all its impressive and explicit features of the telescope, there have been some comparisons drawn between the James Webb Space Telescope and the Hubble Space Telescope, which was launched way before the JWST. In today's video, we will see what are the 10 most insane differences between these two telescopes. This video is going to be very exciting, so make sure to subscribe to our channel and turn on the notification bell now. Without any further ado, let's jump right into the video. The Hubble Space Telescope, or the Hubble as it's referred to, is a space telescope that was launched in 1990 to orbit the lower part of the Earth, and it still very much remains in operation. But this was not the first space telescope to be launched, but the Hubble is one of the largest and most versatile, which is renowned both as an important research tool and as a public relations boon for the astronomy industry. The Hubble Space Telescope is named after astronomer Edwin Hubble and is also one of NASA's great observatories. The Space Telescope Science Institute, or STSci, selects targets captured on Hubble and processes the resulting data, while the Goddard Space Flight Center, or GSFC, is in charge of controlling the spacecraft. The James Webb Space Telescope is a space telescope which is specifically designed to conduct infrared astronomy. It is the most powerful telescope to ever be launched into space, and it has the amazing ability to greatly improve infrared resolution, and its sensitivity will allow it to view objects which are too old, distant, and faint for the Hubble Space Telescope. This new space telescope is expected to bring answers to a broad range of investigations across the fields of astronomy and cosmology, where observations like the first stars and the formation of the first galaxies can be seen, and detailed atmospheric characterization can be done on potentially habitable exoplanets. This JWST telescope was launched on December 25, 2021, aboard the ESA's Ariane 5 rocket from Kourou, French Guiana, and as of April 2022, it has been reported that there are some tests taking place and alignments being made to the space telescope, and it is expected to be operational by the end of June 2022. After the launch of the JWST, there are said to be some impressive progressions and changes that the astrophysics industry will go through when compared to the Hubble telescope because of how different and better the JWST is. Here are the 10 most insane differences between the Hubble telescope and the James Webb Space Telescope. 10. Wavelength. Webb is said to primarily observe the infrared and to have 4 science instruments to capture images in the spectra of astronomical objects. These instruments are said to provide wavelength coverage from 0.6 to 28 micrometers, or microns. 1 micron is equal to 1 times 10⁶ meters. We can also expect the infrared part of the electromagnetic spectrum to go from about 0.75 microns to a few hundred micrometers. If this is possible, it will mean that Webb's instruments will work primarily in the infrared range of the electromagnetic spectrum, with some additional capability in the visible range, in particular in the red and up to the yellow part of the visible spectrum. Thus, the instruments on Hubble can observe a small portion of the infrared spectrum from 0.8 to 2.5 microns, but its primary or main capabilities are in the ultraviolet and visible parts of the spectrum from 0.1 to 0.8 microns. 9. Orbit. The Earth is about 150 million kilometers away from the Sun, and the Moon orbits the Earth at a much closer distance of approximately 384,500 kilometers. The Hubble Space Telescope orbits around the Earth at an altitude of around 570 kilometers above it. But Webb will not actually orbit the Earth. Instead, it will sit in between the Earth-Sun L2 Lagrange point, which is 1.5 million kilometers away. Because Hubble, which is at the Earth's orbit, was able to be launched into space with the help of a space shuttle, whereas Webb will be launched on a rocket called the Ariane 5 because it won't be in Earth orbit, therefore it's not designed to be serviced by a space shuttle. It is very important for an infrared telescope to stay cool, which is why the Webb has a solar shield which will block light from the Sun, Moon, and Earth at the L2 point. This is something that the Hubble doesn't have, hence why it orbits the Earth. 8. Decades apart. Hubble, which was launched in April 1990 into low Earth orbit, or orbiting the Earth at a lower altitude, is more than 3 decades old But it has been an immense help to us by getting an idea about how massive the universe looks by capturing beautiful and mesmerizing images. The James Webb Telescope, which was launched in December 2021, is specifically designed to see things 10 to 100 times fainter than Hubble, all thanks to the up and developing technology. 7. Images captured. During a news conference before the launch of Webb, Klaus Pontoppidan said that the images that the JWST telescope is going to capture will be far better than the ones captured by Hubble. He also said that images would also look kind of different because of the different wavelengths they are captured from. Furthermore, Webb has the ability to, and is specifically designed to, firstly detect infrared light, which will lead to giving us unique and stunning images, whereas Hubble, on the other hand, can observe light at an optical and ultraviolet wavelength. 6. The South Atlantic Anomaly. The South Atlantic Anomaly is a small place where there is a small dent in the Earth's magnetic field, which can impact satellites. The Hubble telescope is said to pass through this weak spot about 15% of the time. However, for the Webb, it is estimated that it will not cross paths with a small dent in the Earth's magnetic field. 5. Delving deeper. Another new feature of Webb is that it is expected to go beyond Hubble's range so that it can behold light from the universe's first stars and galaxies, revealing how the stars looked approximately 13.7 billion years ago. 4. Instruments. Something that is more interesting about the Webb telescope is the instruments which provide it with an upper hand over Hubble. It is reported that Webb has 4 scientific instruments along with a 21-foot tall mirror that measures 6.5 meters in diameter, which is much smaller than compared to Hubble's 2.4 meter wide mirror. A bigger mirror is said to offer the telescope a bigger collecting area or viewing area, which will also provide a wider field of view in the universe. While the Hubble telescope, when compared with an object, is the size of an average school bus, the Webb telescope, with its fully unfolded heat shields, is said to be as big as a tennis court. So, judging by the sizes of both these telescopes, we can see why and how much more the Webb has in store for us in terms of its features. 3. Differences in infrared. In the Hubble, it is said that it can see the light in wavelength range from about 200 nanometers to 2.4 microns, whereas Webb's range will go as fast as about 600 nanometers to 28 microns. According to the estimates and reports, it is said to have added that visible light ranges from about 700 to 400 nanometers. Even though Webb mainly observes infrared light, it can still be able to see the red or orange portion of the visible light spectrum. This is because the gold coating of its mirrors is said to absorb the blue light from the visible spectrum, but it does reflect yellow and red visible light that can be detected. 2. Difference in area of expertise. While Hubble's main area of expertise is to observe light in ultraviolet, visible, and near-infrared wavelengths, Webb has been specifically designed to only observe the light in near and mid-infrared wavelengths. Infrared light is the type that has traveled billions of kilometers in the universe and has gotten stretched as the universe expanded over a period of time. Collecting these infrared light will be helpful in major cosmic discoveries, as these expanded beams tend to carry information about their point of origin during the early days of the universe, thus offering us a sneak peek into our past as to how the universe came into existence. 1. The power of infrared. According to NASA, by observing the space in infrared, JWST will help the scientists to see and explore much further out into the universe with the help of its larger mirror. Also, it gives it more surface area to collect light, enabling the scope to peer even farther out into space, which is extremely important as it allows scientists to look at the universe from billions of years ago. If you enjoyed this video and want to watch more videos like this, then hit the subscribe button and ring the bell icon so that you will never miss any updates.